Assalamu alaikum everyone. Today we are going to look at an IGCSE exam question. So let's get started. ABCD is a kite with diagonals AC and BD drawn on a centimeter square grid with a scale of 1 centimeter for 1 unit on each axis. A is the point with coordinates -3, 4. The diagonals of the kite intersect at the point M with coordinates 0, 2. Given that AB is equal to AD is equal to 6.5 centimeters and the x coordinate of B is positive, find the coordinates of B and D. A lot of information in this question. So to solve this, the first thing I'm going to go and do is try and sketch a grid. Now this is not going to be accurate. It's just going to give me a rough picture of what's happening. So I've drawn my axes, let me label them. So this is my x-axis, y-axis. Let's draw in the arrows as well. That's my origin. A is the point -3, 4, so -3, 4. Let me just randomly put a point here. That's A. Coordinates are -3, 4. The diagonals of the kite intersect at the point M, 0, 2. So 0, 2 should be lower than this one. So let's say there. And that point is M. And write down the coordinates here 0, 2 for M. AB is equal to AD. They are both 6.5 centimeters. So let's say B is somewhere here. I'm going to draw this diagonal first. Oops. Let me choose the straight line tool. So we'll go here. We go. I'm going to just extend it a bit. And B over here. And D over there. And let's join them up. Ooh, actually, I need to change the location of B and D because, as the question states, that the diagonals meet at M, so this line has to go through it. So that's B, and that's D, and that's roughly the location. It's not the exact location. There we go. I'll just connect the points to complete the kite. Okay. Now, a few properties of a kite. So this blue line over here would split the kite into two congruent triangles. And the red line and the blue line, the diagonals, meet at 90 degrees. So it's the blue line is like a line of symmetry, although it's not exactly a line of symmetry on this diagram. It should be like that. Okay. So if I was to find the gradient of the blue line, which I can do because I have the points A and the points M, the coordinates for the points A and the coordinates for the points M, I can find the equation and the gradient of the blue diagonal. So the red diagonal should be perpendicular to the blue diagonal, and I can use that fact to find the equation of the red diagonal. So that's my first starting point. So I'm going to start off over here. I'm gonna number these steps as I go along because there's gonna be a lot of steps. So number one, first, let's say this is equation of equation of AM. So A has the coordinates minus 3, 4, and M has the coordinates 0, 2. I'm going to label this x1, y1, this one x2, y2. Then to find the gradient, it's the vertical difference divided by the horizontal one. So y2 minus y1 over x2 minus x1. Now y2 is 2, y1 is 4, x2 is 0, minus x1 is 3, 2 minus 4 is minus 2, 0 minus minus 3 is 3. So the gradient for this line AM is minus 2, 3. And the y-intercept I can see is 0, 2. So the equation of this line is y equals minus 2 over 3 x plus 2. Right, now off to the second step. So I'll just draw a line here to separate this section off. Here we go. So step number 2, we are going to find the equation of BD. Okay, since the red and blue diagonals are perpendicular, their gradients shouldn't multiply to give you minus 1. So minus 2 over 3, which was this gradient here, times the gradient of this line, the red line, is equal to minus 1. Or you could just go for the negative reciprocal. So times 3 divided by minus 2. I'll take it step by step. Though I am short for space, but I can move the board around, I guess. So minus 2 times m is equal to minus 3. Then I divide both sides by minus 2. Gives me m equals 3 over 2. Okay. I can also write this as 1.5. Either way is fine. So I've got y equals, again, the y-intercept is 0, 2. You can see that from the diagram. So I'm just going to write it as y equals 1.5x plus 2. And that's the equation of BD. Now I forgot to label something on here. It said AB is 6.5 centimeters, and so is AD. Okay. So I'm going to now imagine a triangle AMD. And A is over here, M is over there. AMB, not AMD. Let me correct that. B is over here. Now the length of this is 6.5 AM. So the coordinates of A is minus 3, 4. The coordinates of M are 0, 2. So to find the length of AM, what I'm going to do is I'm going to create a second triangle. Let's move this question slightly up. So I've got some space over there. So we've got AM. This is 0, 2. And this is minus 3, 9. So from this gap over here is going to be 3, because it's 0 minus minus 3. So it's 3. And this gap here, why have I got minus 3, 9? It's minus 3, 4. Be a higher point. It's not to scale. And that gap should be 2. So to find the length of AM, I can say AM squared is equal to 2 squared plus 3 squared, which is 4 plus 9, which is 13. So AM will be square root of 13. So here I can write AM as root 13. And then to work out BM, I can say BM squared is equal to square, oh, 6.5 squared, which is the hypotenuse, minus root 13 squared. Let's see what 6.5 squared is. The IGCSE exam is just calculator paper only. So it's 42.25 minus 13, which is 29.25. That's BM squared. So BM be square root of 29.25. So that's the length of BM. Now at this point, I am now going to try and find out the coordinates of B. In order to do this, I'm going to create a third triangle. Let's do number 4 here. Okay. Again, these are not to scale. Okay. So I'm going to say this is B. The coordinates of B I'm going to call X and Y. And M, we know the coordinates are 0, 2. And BM, we know its length is root of 29.25. We just worked this out. So the width of this is going to be x minus 0, which is x, and this height would be y minus 2. So using Pythagoras theorem, I can say x squared plus y minus 2 squared is equal to root of 29.25 squared. So before I carry on, I know that the equation of BM, or this red line, uh, B equation of BM is the same as equation of BD. So y is equal to 1.5x plus 2. So where y is, I can actually replace that by substituting this part, 1.5x plus 2. So I'll say 1.5x plus 2 minus 2 whole squared is equal to 29.25. Now the plus 2 and minus 2 cancel out. So I've got x squared. Now 1.5 squared is 2.25. So that would be x squared plus 2.25 x squared is equal to 29.25. So that is 3.25 x squared is equal to 29.25. Then I divide both sides by 3.25. gives me 9. So x squared is 9. And then finally I square root both sides. So that gives me the x value is 3. And then the y coordinate would be y equals 1.5 times 3 plus 2. So that's 4.5 plus 2, which is 6.5. So the coordinates of B are going to be 3, 6.5. Okay, so that's one part of the question answered. So B has coordinates 3, comma 6.5. Now we have to find the coordinates of D. So I'm going to finally come over here. I'm going to draw a line. And on this line, I have 3 points, B, M, and D. So the top line is B, its midpoint is M, the bottom point is D. And why is the midpoint M? Remember earlier on we mentioned that this blue line was the line of symmetry, so it splits that red line into 2 equal parts. We now have the coordinates of B, 3, and then 6.5. We know the coordinates of M was 0, 2, and D I'm going to call X and Y. So using, we know how to find the midpoint, so we add the two x coordinates divided by 2. So I can say 3 plus x, those are the two x coordinates divided by 2. That'll give you the x coordinate of the midpoint. That's equal to 0. And then I solve for x. So I multiply both sides by 2. So I get 3 plus x is equal to 0. And then subtract 3 both sides. So x equals minus 3. Now, again, I'm going to do the same thing for the y coordinate. So my y coordinate would be 6.5 plus y divided by 2 is equal to 2. And the same thing, multiply both sides by 2. So 6.5 plus y is equal to 4. Then you subtract 6.5 both sides. So y is equal to minus 2.5. So the coordinates for D should be minus 3 minus 2.5. Now, there's one way to verify it, I believe. Let's see, let's go. Yep, so BMD, we have the equation for it, y equals 1.5x plus 2. So let's do the verification here. Y equals 1.5x plus 2. Let's substitute the minus 3 value. So 1.5 times minus 3 plus 2. That's minus 4.5 plus 2, which gives you minus 2.5, the same as this. So finally, the coordinates of B were 3 and 6.5, and the coordinates of D were minus 3, minus 2.5. 7 marks for this question. A lot of hard work involved. Well, I hope this helps, and thank you for watching.